Hi everyone, welcome to the lecture for Chapter 10, which is all about air quality. So today we're going to talk about what air quality is, things that can affect air quality, and ways in which we regulate air quality. So your book gives an example of killer smog, basically, which is a deadly air pollution. So in 1948 in Donora, Pennsylvania, there was a zinc smelting factory and smog was very common there. So this type of air pollution, especially before we passed the Clean Air Act and had the EPA, that heavily regulated the types of pollutants that could go into the air. Having smog like this was fairly common, but on this event in 1948, basically you had these weather conditions where you had this warm air that was capped by this cold air, and so the smog was trapped and couldn't go anywhere. These types of killer smog events, there was one in London that was actually much, much worse than this one that caused them to change their environmental regulations. But basically this pollution gathering and sitting and not being dispersed led to 20 people dying and thousands being ill. So you can imagine that if you have asthma or your health is compromised in some other way, an event like this can be very, very serious for you. And so this event led to the Air Pollution Act of 1955 and then the Clean Air Act of 1967, which I'll talk about a little bit later. So we still deal with air pollution in the United States from a variety of mechanisms, including things like our cars, and we'll talk about some of that. But we still have deadly air events. And so just very recently, we had the Paradise Fires in Northern California. This is a picture of the Bay Area, of what the air pollution settled in and looked like there. And I'm sorry, this is not the Bay Area, this is Chico, but settled in places like Oakland and San Francisco and Sacramento, and went fairly far south. But in some places, the air quality was just extraordinarily hazardous. People were told not to go outside. And those, again, who had some type of compromised health were especially susceptible to being harmed by an event like this. And this air pollution hung around for quite a while after the fires. So first of all, we're going to talk about what do we mean by air quality and what do we mean by air pollution. Oops, excuse me. So air quality is gases and small particulates in the atmosphere that influence ecosystems or human well-being. So we talk about what is in the air right now and how is that affecting ecosystems and human well-being. You can talk about this in a very basic way of like the pollen count in the air, and if you have a lot of allergies, right, that can affect you. You can go online and look at air quality reports for where you live. If you go to airnow.com, the EPA releases these air quality reports, and you can look at an air quality map and see what that looks like. Air pollution is when gases or particles are in high enough concentrations that they harm humans, organisms, and structure, right? So air quality is just looking at what is in the environment that can influence human well-being and ecosystems. But now when we get to air pollution, those concentrations are high enough that they have the potential to affect your well-being. So we can see here there is a cyclist wearing a protective mask in China in order to kind of filter out some of that air pollution. Unfortunately, those masks are often not that helpful in removing a lot of the pollutants that are particularly harmful. So in China, they have a lot of air pollution problems due to manufacturing and due to coal-fired power plants, which I'll show you another picture of that in a bit. But and in Sacramento and the Bay Area, people were handing out masks like this. The government was handing out masks like this during the fires in order to help people kind of filter out some of that pollution that they were breathing in. So just to talk about pollution, first let's talk about what is in the atmosphere and what is supposed to be there in the first place. So the atmosphere is made up of primarily nitrogen, oxygen, and argon. That's 99% of the atmosphere. So really what we're talking about is a very, very small percentage of what is in the atmosphere. Nitrogen is the most abundant gas in the atmosphere. I believe it's around 70-something%. Oxygen is smaller. But then after that, we have trace gases, which are much smaller gases. We talk about them being present in parts per million. And some of them are stable, meaning that they're pretty much in the same concentrations everywhere, like helium is quite stable from place to place. But other ones vary widely in place and time. So depending upon the day, the season, the decade, the century for that matter, these trace gases can vary quite significantly. It's one of the reasons that when you look at an air quality report, you have different levels of air quality in different areas depending on what's going on there. We also have volatile organic compounds in the air, and these are chemicals that vaporize into the air. They include a wide range of chemicals. Some of them are produced naturally, such as methane, which is CH4. Other naturally occurring VOCs give flowers and organic matter their kind of odor when that happens. But you have other human-induced sources, including things like solvents and paints and gasoline and exhaust from automobiles. Then we also have aerosols, which are tiny solid and liquid particles that are suspended in air. So you can think about clouds and fog. The size of the particle determines its residence time, and so that means how long it's staying in the atmosphere. So you can see here, this is a graph on the right that's showing the particle radius, or the size of the particle. Viruses, much smaller. Pollen, much, much larger, right? So smoke and fog and smog can stay in the air, generally speaking, much longer than pollen is going to stay in the air because it's much larger. Next, I'm going to talk about two kind of big categories of pollutants. So not necessarily the type like VOCs or aerosols, but how we think of them based upon how they get into the atmosphere. And so the first type is a primary air pollutant, and that is something that is directly released into the air. I turn on my car, the exhaust is being directly released into the air. That is a primary air pollutant. This is different from secondary air pollutants. Secondary air pollutants are chemicals and particles that are formed by the reaction of other chemicals or aerosols in the atmosphere. So basically you have something being released into the atmosphere, reacting with something in the atmosphere, and possibly sunlight. If it's reacting with sunlight, it's a photochemical secondary pollutant if it's being facilitated by sunlight. Ozone is a big one that we get due to the reaction of, if you nitrous dioxide being released, reacting with things in the atmosphere, with the combination of UV radiation, you get ozone, which is a secondary pollution. So photochemical smog, or what we typically think of as this kind of heavy smog that lays over places, is often, it is a secondary pollutant. It is something that is happening in the atmosphere after a primary pollutant is released. We can also think about it in two other ways in terms of point source and non-point source pollutions. So a point source pollution, and this is true for water as well, is stationary, localized source of pollution. So basically, when you want to think about a point source versus a non-point source, you can say, I can point to that source of pollution. So think about it in terms of a smokestack, right? I see the smokestack, the smoke is coming out of the smokestack, I can point to it. That is a point source pollution. Non-point source pollution is where you have numerous sources that produce a relatively small amount of pollution, but cumulatively they have effects. So we can think about things like cars, residential fireplaces, right? If you are in an area where it's cold, lots of people have fireplaces, you get this cold snap, lots of people are burning wood, now you're going to get this cumulative effect. But you can't necessarily point to a single house and be like, you are the cause of this air pollution, right? It's a cumulative effort. The same thing with cars, right? Cars release pollutants into the atmosphere, but it is the combination of all of our cars together. It is not one car that is causing that pollution. And so next I'm going to talk about how pollutants are dispersed and held in the atmosphere. So they are, you have three mechanisms by which pollutants travel through the atmosphere, and that distance and direction is determined by these three factors. The first is airflow patterns. So which way the wind is blowing, right, is going to affect how air pollution is dispersed. You can also get something called temperature inversion, and temperature inversion is where, sorry, those bullets are a little messed up. This is the explanation for temperature inversion below temperature inversion. But that's where you get warm air forms over cold air, and that traps that pollution. So you can see in the picture here, right, we have cold air here, we have warm air here, and it is trapping what is here. It cannot be dispersed any farther, so it's being held locally. The other two factors that affect the dispersion and deposition of air pollution are the height of the emission, so how far into the atmosphere the emission goes, whether or not it's localized and right at the ground, or whether or not it is thrown well into the atmosphere. And then also the time in the atmosphere, so that residence time. Is it coming back down? If it's dry deposition, basically it's particles that are being removed by gravity, right? So things like pollen can be removed by gravity, as opposed to wet deposition, where you have trace particles and gases that are captured by raindrops and droplets of fog that are then going to fall down. So you have things that are kind of attached to water. Those are called, I believe they're called hydroscopic. So basically they're attached to water and then they fall down. So we'll talk about things like acid rain, where you basically get these pollutants that come down as rain. So I just want, your book doesn't give a good illustration of this, but this is kind of a little bit of a hokey one, but us to understand kind of what the atmosphere looks like in the first place. So most of our interaction with the atmosphere happens in the troposphere. The troposphere is the lowest layer of the atmosphere. This is where we spend most of our time. This is where weather happens. This is where the clouds are. We, sometimes just break into the stratosphere a little bit in an airplane, depending upon our height, but that's pretty high. Volcanic eruptions can get up in there. Our ozone layer, which protects us from harmful UV radiation from the sun. But I'm going to talk about pollution in the stratosphere versus pollution in the troposphere, because there are some different factors at play there. So first I'll talk about pollution in the stratosphere. And again, pollution in the stratosphere is above that layer of the atmosphere that we are basically in the majority of our lives, unless we have flown on a very high flight. So the stratosphere is the layer of the Earth's atmosphere that extends from 7 to 30 miles above the troposphere. The pollution in the stratosphere has no direct effect on human health, so it's not like we're breathing in this pollution and it is harming us, but however, it can influence climate. So, and what you probably think of most readily is climate change and carbon dioxide, but what I'm going to talk about is aerosols. So aerosols such as chlorofluorocarbon, which I'll talk about, I'll show a picture of in a second, but chlorofluorocarbons were basically eating ozone, and due to that, they altering the amount of sunlight that was reaching the Earth's surface. So destructing the ozone, causing increased UV radiation due to these chlorofluorocarbons. And so what happened is the countries of the world, amazingly, got together and said, hey, we should stop using these chlorofluorocarbons because in the quantities that we are now, because we are destroying the ozone layer, which again protects us from UV radiation and is very, very important. And they got together and they did that. So you can see here, though the hole in the ozone is still quite large, but they have, by passing this Montreal Protocol, they were able to get together, which is a rarity, I feel like, for a lot of countries to get together and say, we're going to stop using these chlorofluorocarbons. So this is a good example of an international agreement on air pollution. Pollution in the troposphere, there are 3 types that have the greatest impact on human health and ecosystems. The first is acid deposition, which is the dispersion of acid-containing gases, aerosols, and rain onto soils, plants, buildings, and bodies of water. So you can see here is a statue of George Washington that has been affected by acid rain. It forms from sulfur and nitrogen oxides that are emitted by burning fossil fuels. The second is heavy metal pollution that comes primarily from human sources, including metal smelting, which we saw in that original picture, that zinc smelting, waste incineration, the combustion of coal and all fossil fuels. And then third is smog, and smog again is a complex mixture of both primary and secondary pollutants. We live in Southern California, especially if you've spent any time in LA, obviously dealing with smog. And so we can see kind of like dramatic changes in air quality based upon what is happening locally and based upon their residence time. So this is a building, it is called The Nest. It was built for the Olympics in Beijing, and the air quality in Beijing, not very good, as you can see in the top picture. And there were concerns about the Olympic Games and people being able to compete with the air quality. And generally speaking, you know, China didn't want to present this level of air quality to the world as they were showing up. So factories were shut down in the weeks before the opening ceremony. The use of automobiles was very restricted, and then they also had some good weather, and so they had just a huge reduction in air pollution. Another good example is several years ago, the 405 was closed for a day, and it was heavily publicized that it was going to be closed. People were saying it was going to be Carmageddon because the 405 is the busiest freeway in the country. But what actually happened is when the 405 closed, everybody in LA said, we're just going to stay home for the day. And there was a noticeable increase in air quality on that one day just from cars being off the road for that single day. But, regulations in air quality work. We have had catalytic converters in cars since 1986, which has decreased the levels of ozone and associated smog. You can see here, since the passing of that, it reaches its peak around 1986, and then it drops. Part of that is from California has very strict air quality measures, particularly for cars. And so once California passes a law, the rest of the states kind of follow suit, or get the benefits from that rather, because people aren't going to produce automobiles that can only be sold in California. They want to produce automobiles that can be sold in the entire country. So when we look at pollution in the troposphere, basically we can look at the air quality index. The EPA monitors levels of important air pollutions. They have 1,000 sites in over 300 cities. You can go online and look at the air quality at any given area of the United States. And so they calculate this based upon an air quality index. Each pollutant is on a scale from 0 to 500. 100 is the regulatory standard, meaning you do not want something over 100. Ideally, you want something well below 100. Levels over 100 are considered unhealthy or code orange for sensitive groups. During the Paradise Fires, there were levels over 300 in some places. It was incredibly unhealthy to breathe that air. And so you can figure out where you live and what your air quality index is for today and how does it compare to other locations in the United States. And then what factors are likely contributing to the quality of the air that you breathe, right? So in Southern California, depending if it's a weekday and it's heavy traffic, what the weather is like, is it hot? Is there a temperature inversion? Is that smog being trapped here? I grew up in the Northeast and air quality was very different there because based upon wind patterns, we had a lot of our pollution went up and then just kind of went to the east. It didn't get trapped by that temperature inversion like it does in LA. But I encourage you to go online and check out the air quality index, and I'll have a link to it after this presentation. I'm also going to talk about indoor air pollution. Right? We tend to think mostly of outdoor air pollution, but generally speaking, indoor air is more polluted than outside air. And that happens for a variety of reasons, including byproducts of combustion. So we can see here this indoor cooking, which we tend to not cook like this in the United States, obviously, with a wood burning happening directly that your food is cooking on in your house. Right, but this includes things like carbon monoxide, nitrogen and sulfur oxide, those VOCs, those volatile organic compounds, and particulate matter, things like indoor burning and secondhand smoke. We, especially in the United States and in other parts of the world, have really become aware of secondhand smoke and its effects on the people who are not even smoking. We also have all types of air pollution from other things, such as if you open a vinyl shower curtain and that smell that you get off of a vinyl shower curtain, that is a gas that is being released into the air that is actually not very good for your health. And so we can look globally at the number of deaths each year caused by indoor smoke, right? So not high in the United States, but in other parts of the world where you're still smoking indoors and burning wood indoors in order to cook or heat your home, quite high. We can also look at state laws regulating indoor smoking, right? So how do we regulate indoor smoking? In California, we have very strict laws about secondhand smoke. You cannot smoke on the beach. You cannot smoke in any public park, right? These are outdoor, but you certainly unless it is your own home, and if you are renting, probably not even there, where you can smoke indoors. Other places have much more lax regulation. When I was young, I became a legal drinking age now 22 years ago, and everybody smoked in bars and restaurants. There was a smoking section and a non-smoking section. When I was a kid, you could smoke on airplanes, which seems kind of insane now that you could smoke on airplanes, because where is that smoking going? So for your exercise this week, and so this is the prompt from your exercise, we're going to talk about the regulation of e-cigarettes as a pollutant, right? So vaping, also known as the smoking of e-cigarettes, is on the rise in the United States. Lots of you probably know somebody who vapes. It is becoming particularly popular with young people. Especially, a lot of people blame that on like the prevalence of like flavors that you can get, right? It is very kind of easy to vape on the sly, right? You're not having that, if somebody smokes a cigarette, everybody can tell that they smoked a cigarette. So you kind of have two major arguments. Individuals, local governments, and schools are arguing that vaping should have regulations similar to smoking. They argue that we still don't know how the harmful effects of vaping, just like we previously did not know the harmful effects of smoking. On the other hand, e-cigarette manufacturers promote vaping as a low-harm alternative to smoking tobacco. Some have even gone so far as to call e-smoking medical devices because they help people to stop smoking cigarettes, which have been proven to be harmful. And so I'm going to ask you, do you think e-cigarettes should be regulated like other tobacco problems? And what do you think of your state's approach to the problem? So California, I'm going to assume, even though this is an online class, that most of you are in California, has pretty strict regulations with e-cigarettes. They regulate them just like cigarettes. Other people argue they should not be regulated just like cigarettes because they are quite different. And people feel that the secondhand potential of pollution is very, very low. And they are getting lots of people to quit smoking. Also, sources of indoor air pollution include construction materials. Many construction materials emit those VOCs like I talked about before, things like paints, adhesives, synthetic fabrics, wood preservatives. It's funny, everybody likes that new car smell. It's not really good for you. I don't recommend breathing that in. Also, we used to use asbestos. That's what this picture is right here. Asbestos is this fibrous material that was used for heat and fireproofing. And we now know that breathing in the fibers leads to lung disease and cancer. It was banned in 1973, but lots of buildings still have asbestos in them. And so when you, for example, when Storm Hall was being renovated on campus, they're pulling out things that have asbestos in them, so you have to be very careful in how you dispose of asbestos. So how do we regulate air pollution? What is the policy and law that we use to regulate air pollution? So we can also think of biological contaminants, which are a buildup of virus, bacteria, or fungi. Probably one of the most well publicized ones is Legionnaire's disease. Legionnaire's disease you can also get from drinking water, but basically it is a bacterium that builds up in air conditioning systems due to that moisture that's in there. And then it's transmitted as an aerosol in a hotel lobby. And so you can get this disease, Legionnaire's disease, which is basically like a pneumonia disease. And so it is named because at an American Legion convention in Philadelphia in 1976, over several days, 221 people became sick and 34 people died from the disease. And after the Centers for Disease Control studied it, they realized the outbreak was Legionnaire's disease, which was named for, which is a previously unknown bacterium. You often hear about Legionnaire's disease or concerned about it on cruise ships. Basically, having effective water and air management can reduce the potential for Legionnaire's disease. policies to control air pollution have changed substantially over the past 60 years. So we kind of get this new environmental movement that happens in the 60s and 70s when we get things like the Clean Air Act and the Clean Water Act. But basically, there's a public outcry after tragedies such as the killer smog that happened in Pennsylvania. So we get the Air Pollution Act of 1955, which is where the standards for air pollution are set by the state. That was signed by President Eisenhower. And then from 1963 to 1990, you see the responsibility for this shifted to the federal government with the enaction of the Clean Air Act, which the EPA regulates emissions from stationary sources such as factories and power plants. And the Clean Air Act, right, made a large difference in air quality, just like the Clean Water Act made a large difference in so on average, air pollution has been consistently decreasing. This is the concentrations of sulfur dioxide since these acts have been implemented. There is also international policy and law. So I talked about the Montreal Protocol on ozone way back when, but you can see chlorofluorocarbon emissions. Montreal Protocol is passed, they drop. Likely trajectory without it. So that definitely worked, right? That was aimed at reducing the destruction of the ozone and established a timeline for protocols phasing out CFCs and ozone destroying substances. And so what we'll talk about when we talk about climate change also is whether or not the EPA can and should regulate greenhouse gases and its effects on climate change and human health and well-being. That is the end of the lecture for Chapter 10. Now I'm going to provide you with a link to go look at your air quality. You're going to do your assignment for this week and then move on to your